This is about the coarse aggregate. Now we'll go about the fine aggregate. Fine aggregate is playing major role in concrete. Coarse aggregate is not much, because whatever fines material is there, it demands more water, more surface area, more paste, and all other issues. All are basically because of material which is passing 4.75 mm, or roughly we can say is a 5 mm. It's called fine aggregate. So these are the materials you can see here. This is river sand. Now crushed stone sand, which is rock, you break 20 mm, 10 mm, and further you crush it with the proper equipment and make it into the particles of sand. So it's called crushed stone sand. And when you are making 10 mm, 20 mm, in that process also some fines are generated in the quarry. It's called a crusher dust. So this is not advisable to use in quality concrete. So you must, as an engineer, you must know what is the difference between crusher dust and crushed stone sand. So once you know this, it's very easy. See here, big particles are there, flaky particles are there, coarser is there, and then fine. Here, all graded material is there. Now this natural sand is not available, at least in Mumbai, is not available, and most of the part of the country is on banned due to the environmental conditions. So one has to understand the particle shape, size of the particular. So crusher dust is not advisable to use in quality concrete. You can use for PCC, leveling course, other thing, because it is very cheap material and no processing is there. Here, it is processed material is there. So crushed stone sand is very, very important to know. Then fineness modulus basically is a calculations. So weight retained on sieve from 10 mm to 150 micron divided by 100. The value comes in. This also indicates the fineness of your fine aggregate. This is the coarser, your sand is coarser. Once the figure is fine, you get fine is fine. So this is an indication. Looking at the fineness itself, you will know whether your sand is coarser or sand is fine. So that you can find out. But for that, you need to do the sieve analysis. Now in fine aggregate, generally in the river sand, you get the silt clay content, sound. These are all other, and then organic impurities. Sometimes you get soft particles like wood, coal, other things are available. For mixed design, we need to know grading, specific gravity, water absorption. This has to be done regular basis. And based on your sieve analysis or particle size distribution, you must change the proportioning of your materials, 20 mm, 10 mm, and sand. And bulkage test is there, but now it is not much applicable for your crushed stone sand. But all the tests are given in IS 2386. Those are interested in to see this, they should go for at least once or two. They can do all the tests. That as an engineer, you must know all the tests. Whatever we have discussed, should know in thoroughly. Now, like aggregate, we have seen in 10 mm and 20 mm, 40 mm, 80 mm. Your fine aggregates are divided into zone 4, zone 1, zone 2, zone 3, and zone 4. Always we are calling as a zone 1 to zone 4. Now this is the coarser zone and this is the finer zone. Now how to decide these zones? The material which is passing 600 micron, that decides your zone of that particular sand. See, all are overlapping. 90-100 is there, 75-100 is there, 55 again here is there. But here there is no overlapping. You see, 1534, 3559, 6079, 8000. Suppose you have a report of sieve analysis, percent passing. Looking at this 600 micron passing, we'll understand the sand from which zone it is belongs to. And whatever design given in IS 10262, which is guidelines for mixed design, they base the mixed design on zone 2. Their calculations, whatever they are considered. And they are given adjustment for zone 3 and zone 1. This is coarser material, this is finer material. Accordingly, you adjust your fines to coarse ratio. And it's not advisable to go for zone 4 sand for RCC work. It's very, very fine material. It's not advisable to you in this RCC work. Now this, all this grading they are given here 150 micron, 010 and here 015 because it's very fine. When you go for cruststone sand, this limit has increased to 20%. Because in the process itself, you are generating a lot of fines. So when you go for cruststone sand or whatever right now available in the Mumbai and other area, we don't get natural sand in Mumbai. So there this limit has to go to 20% for this limit. So in this you have to remember one thing, zone of sand, that is material passing through 600 micron, and then material passing to 150 micron. For cruststone sand it is increased to 20%. This 2.1 has to remember. And all the mixed design process or mixed design methods described in IS 10262, that is the guidelines for mixed design based on zone 2. And you do other adjustment accordingly. That when we discuss in mixed design, we carry out some examples and find out how to go about mixed design. This is what I discussed. As I said, sugar is also the impurities for the concrete. So clay particles, shell, mica. Mica is also sometimes available in the your sand. Whether agates having more water absorption, clay particles require higher water absorption, higher shrinkage, and sugar may go for the retardation. There is a test also given for organic impurities we can do in the site itself and compare the color. This is, we have to use NaOH solution, 3% NaOH solution, sodium hydroxide, and put into the glass like this, and this will form a color. This is the silt, but whatever impurities are there is reacting with sodium hydroxide and form a color. And that color you can find like this. So this is our acceptable limit. This is not acceptable. So once this color is formed, then you'll have to go for the wash the material and again recheck. Once it is coming to this, we can use in concrete. Otherwise, you should not use in concrete. This is for organic because a lot of industrial waste coming in the river water and that carry with your sand. So this is for basically a natural sand, not for the cruststone sand. Even coarse aggregate also there's a lot of dirt on the aggregate, high silt, fine content, unacceptable shape, as we have discussed, and improper grading. This is all affecting your low strength of concrete. If you have not done the proper adjustment in the mix design. And then going for the higher strength, you increase your water content. Then you increase your cement content. Then cost goes up. But it is better you go for the good aggregate. Maybe initial cost cement consumption is reduced and overall cost can be controlled. Now next come is your particle packing. I think we have discussed this, but again we'll go for this. Like this. Suppose you have single size and these are the voids. Now these voids we can fill with the another finer materials. This is basically a called a properly packing of material right from 20 mm to 150 micron. So your proportioning should be such that I should have minimum void content in the when you mix in the dry state. So if you take the density of this, you will find with the particular proportion we get higher density, higher compacted density. If you use that proportion, definitely your water demand is less, paste demand is less, and your water content or water cement content also will be less with the higher strength. So it's very important to understand how you proportioning your 20 mm, 10 mm and fine aggregate for the proper concrete. Like this, you see. These are the voids. And once you add fine material, it reduces the voids in the sense that voids are reduced, required less pest content, less water content, and more strength. And there is also mechanical packing, so you get very good strength. So you have to optimize the blend having high packing, low amount of paste. As a result, they are less expensive and less durability problems caused by the pests such as heat hydration, porosity, and drying shrinkage. Because paste, higher paste will have a lot of shrinkage also. So, as a concrete technologist, our aim to go for the maximum possible packing density. That is the basic thumb rule of mixed designs. Mixed design is nothing but proportioning of material properly, select water demand, select the cement content. You will find that if you do proportioning properly, your concrete mix will be very effective in the with the cost. This we discuss. So best mix vocabulary typically came from the densest packing of sand and coarse aggregate. Sand you can say crusstone sand. So, and consequently one of the objective to optimize the concrete mixtures to combine available aggregates in such a way that maximum or near to maximum packing degree is obtained while maintaining acceptable level of vocabulary. This one has to remember as a concrete technologist to have a good concrete technologist making good economical concrete with the within the budget. You can go for such things. This is we'll discuss. I think we don't have much time. This is how combination do 60-40, 50-50, 65-35, 45-55. When you go for mixed design, we'll discuss this in details. So workability target requirement, size of particles, grading, shape of the particles, and surface texture is very important. These are also you have to understand and proceed for your mixed design. This is one video is there. So this video actually whatever we are discussed about the shape, just give very good clarity about the concept and crushing. Now this is flaky material. So this is what is discussed. Surface texture, as I said, influence the workability, cement requirement, interlocking, strength and durability. Texture is also influence on the concrete workability because you need a workability proper. In laboratory, we can make us concrete, but concrete has to produce, transport, place, and compact. So all the point you have to consider when you go for the proper design. I got another video. You can see the shape here, natural sand, and there are very smooth surface. This is the stone. See, these are the stone having elongated and flaky material, having very rough surface. Stone dust, the stone sand. See here, this is what segregation takes place in the quarry. And sometimes you get coarser material, sometimes you get fine material, and that is affecting your continuous production of concrete. This is what impurities we are talking about in the aggregates. See, this is the cross section of your aggregate concrete. See these aggregate shapes. We are basically desired to have such aggregates, angular aggregate. See, this is angular aggregate. Now you can see this video, how this crushed sand is making. What is the concept, how the working. Just have around 2 minutes video right now. This is how inside, how it looks like crusher, VSI, vertical shaft impactor. So this aggregate going in, and by centrifugal force, it is coming on the surface here. There no direct touching is involved in this. See, and because of this shape, you get the angular aggregates and good surface finish. This is responsible for getting a shape. So this is how your crust on sand is making. This is called vertical shaft impactor, and for that, and then we can check the materials of various 75 micron. What is the size graphically, and then you can find out which is better for your concrete. There is also one small video is there. Let us see this. If you use crust stone sand and then processed sand, which is properly processed, how is affecting the slump and flow. This is all Japanese technology. Now such machines also available in Mumbai now. They're similar to slump test. This is a conventional sand. We have talk about stone dust. You see the mix. See the same mix, same water content, how the mix looks like. That is V7. So this is the difference between the same. If you same sand, if you process properly, you get. This is one of the project we have used 100% crust stone sand in Pune, Amnora project. Okay, for such a high 22-story pumping, all these issues you have to address when you are designing concrete with crust stone sand. We'll discuss when you are going about mixed design.